then I can give you like 60 seconds to answer these or to try them. You will not be able to get a lot of them done before I do them with you, but hopefully you can at least get a start. Like right now, if you got here on time, I'm sure you've had the opportunity to at least get this one started. All right, remember, I'm only giving bonus on your cam done if you answer every question on Desmos.
Hey, Mr. Tamanka.
Yes.
My connection's being really slow, and I don't know if my camera's on or not. There's like a caution mark on there.
Your camera's on.
Is it on or no?
It's on.
All right, sweet. We're chilling. Wait, it's off?
It's on. Do you know that you could have just said,
okay.
Mr. Tanaka, can you see me? That's all you could have said. But thank you for the background story. All right, here we go.
Well, that's not very specific.
All right, here we go. Here we go. Antiderivative of 4x. That's a power rule. So that would be 4x, add 1 to the exponent, but make sure you divide by it. Okay? Plus, what's the antiderivative of secant squared x? Well, the antiderivative of secant squared x is tangent x. How do I know that? Well, I know it because the derivative of tangent x is secant squared x. And then I'm going to evaluate this from 0 to pi over 4. Now remember, I should simplify this first. That would be 2x squared plus tangent x. Ooh, I love it that some people already have an answer in Desmos. Okay, and remember, using the FTOC, you always plug in the top guy first. So I would plug in a pi over 4 in for every x. And then I would plug in a 0. I would subtract, and then I would plug a 0 in for every x. Ooh, tangent of 0. So if I simplify this, this gives me 2 pi squared over 16 plus tangent of pi, we better know, is 1. And then that would be minus 0 plus tangent of 0 is 0. So my final answer for this would be pi squared over 8 plus 1. Type that into Desmos so you get bonus, you guys. Now, in section 5.4, you had a lot of problems to practice. A lot. So I hope you guys did your section 5.4. Okay, I really, really do. All right? And like I said, for some of these things, we're going to be going through them quickly. Don't freak out about it, all right, you guys? Just ask questions if you got them. If not, I want to get through this. And once again, I am very scared, but I'm probably going to, my computer's probably going to shut down. Okay, it did 2 times last hour. If it gets shut down, you work on your Desmos. Give me a thumbs up. Everybody good, yes? All right. Every time I say, do you have questions, you got to give me a thumbs up or a question, or you disqualify for the bonus. All right, here's a question. They gave me a table. And in this table, they're asking me one of these questions: LRAM, RRAM, MRAM, or the trapezoidal rule. AP loves to use tables. This question here, if you read very, very carefully, asks you to use the trapezoidal rule to estimate the amount of widgets. Well, R of T stands for widgets per hour. T stands for hour. So if I find the area of widgets per hour to hour, it gives me the total widgets. They don't even tell me how many intervals to use, but they tell me to estimate it over an 8-hour period. Hopefully you guys have an idea of what to do using the trapezoidal rule, which really just means you need to know the area of a trapezoid. But remember, whenever we do LRAM, RRAM, MRAM, or trapezoidal rule, we break it into like intervals: 0 to 2, 2 to 3, 3 to 6, 6 to 8. And once again, I'm going slow for a reason, so that you actually try to get something down on your own. All right, and so what would I do here? I would just take 1/2, and this, believe it or not, would be non-calculator. 1/2, the height of the first trapezoid would be from 0 to 2, which would be 2. And then my widgets per hour, or my bases, would be 12 plus 14. That's it. That's it, you guys. Plus 1/2. My next height, though, goes from 2 to 3. That's a height of just 1. And then my B1 and B2 would be 14 and 10. My widgets per hour. And I'm going to multiply it by hours, which gives me widgets, total amount. And then I got 1/2. My next one goes from 3 to 6, which would be 3, 10 plus 12, plus, and then I've got one last one to do. I'm going to go from 6 to 8, which would be a height of 2. I'm going to do that 12 to 9. All right, now this would be a non-calculator would be my guess. Why? Because you could take 1/2 of 2, which goes away. And for this first one, you get 26. You could do 1/2 of 24, which would be 12. Right? So usually it's quick and easy if it's non-calculator. A 10 and a 12 gives me 22. If I take half of that, that's 11 times 3, which is 33. Right? Be efficient. I wouldn't take a half of 3. That'd be silly, right? I take a half of the even number. Okay, and then the last one, I take half of 2, goes away, and I end up with 21. If you add all those things together, you get 92. All right, so the question is hopefully that's okay. What if I ask for LRAM? What if I ask for RRAM? What if I ask for MRAM? Would you be able to do it? I hope so. I hope so. If you can do everything we do today, you should be able to get a B, no problem. Okay, no problems. Are there any questions? I need thumbs up or I'm not giving you bonus. DeFore doesn't want bonus. Okay.
Whoa. So for like, let's say it was for MRAM, but it was for like an odd amount of sequences, like how we have it right here. How would we do that? Would we have it in like separate intervals? Like it would be from 0 to 3, then from 2 to 6, then from 3 to 8.
DeFore.
So we would.
DeFore, you're a smart dude. Yeah. He's a very smart dude. MRAM is the one where it would be a little bit iffy, but you would have to break it up into like 0 to 3 because you would need a middle. So he stated that beautifully. Great job, DeFore. That's wonderfully, wonderfully done. Wonderfully done. And yes, you would have to be given more intervals in order to do an MRAM for that problem. Kudos to you, young man. Now listen, this one is not in Desmos. It's not in your notes, but you have a lot of these. I don't expect you to write it out. So just everybody pay attention. That's it. Okay, everybody pay attention. Just see if you can answer these questions while I go over them. This is the star problem. There's 3 major star problems we're going over today. The 3 that you better not miss, where if you miss them, you're going to get a C or D. You are. Don't miss them. Okay, this is the one where I give you the graph of F, but then I introduce this G function. And G of X, it says here, you guys, is equal to the integral from 0 to X of F of T dt. Okay? So then the first question asks, what's G of 0? So you guys should just all by yourself answer these questions. What's G of 0? Well, if it goes from 0 to 0, we all better know the answer is 0. Give me a thumbs up if you beat me to that. Okay, and if you can beat me with these answers, it means you're ready. What's G of 1? Well, G of 1 means I put a 0 in for X. I mean a 1 in for X, I'm sorry. And if this was my question, we all hopefully know that this integral symbol means the area from 0 to 1. And that is a triangle. That's a triangle that's 1/2 base times height, which is a 1/2 base. That has an area of 1. But since it's below the x-axis, I better put an answer of -1. Give me a thumbs up if that one's okay. Man, I'm seeing a lot of good thumbs up. And this is a huge one. This is a huge one, you guys, okay? And then the next one is the toughest one. It's G prime of 1. Well, how the heck do I find G prime of 1? Well, in order to find G prime of 1, you need to know what G prime of X is. Now, I really hope you guys know that G prime of X would be the derivative of an antiderivative, which means you use the FTOC, you plug that in, you plug that in. If I plug an X in, it just becomes F of X, and then I take the derivative of X, which is 1. Okay? If I plug in a 0, that would be a constant, and if you took the derivative of a constant, it just goes away. So G prime of X is really just F of X. So G prime of 1 is really just F of 1. Well, what's F of 1? Well, hey, it's just wherever it is on the graph, which is at -2. If you got that one right, you are doing an amazing job. Give me a thumbs up if you understood that. Wow. So I've got a lot of you doing a great job. Now, my guess is if you really spend time with the review, if you watched my video that I made on it, you probably got all of those questions correct. All right, let's take it next level. What would next level be? Concavity. Concavity for G. Well, concavity for G would mean the second derivative of G. But they don't give me anything about G except its relationship with F. So if I recall, G prime of X was equal to F of X. So G double prime of X would be equal to F prime of X. So the second derivative is really the slopes of F. So if I did concavity, I could do a sign analysis. And on my sign analysis for concavity, I put critical points for G double prime, which are actually critical points of F prime. So where is F prime 0 or DNE? F prime is 0 or DNE at 1. Why? Because there's a pointy place, which means it's DNE. There's actually a pointy place at 3, you guys. Do you see it? The slope changes. The slope actually changes at 3. It's kind of like here, and then it flattens out a little bit. So there's actually a pointy place there, and then there's a pointy place at 6. So those are all critical points. Why? Because they're critical points for F prime, right? It's a DNE slope. And then the slopes are negative, then they're positive, then they're positive, then they're negative. So when it asks for a concave up, I would want to know when the slopes are positive, and the slopes are positive from 1 to 3, union 3 to 6, because G double prime is equal to F prime, which is bigger than 0. I just need a thumbs up if that's okay, or a question. Now, if you could have gotten that on your own, you are just money. You are money. Does anybody have a question? Ooh, a hand up. Go ahead, Beaker. I like using that hand up on Google Meets.
Okay, so is there like another way that you could say that statement? Like, could you say that G prime of X equals F of X, so the slope of F of X equals G double prime of X?
Yes, that works. Yeah. And then it would be concave up wherever the slopes of F are positive. So that's another way you could say it, okay? Or where F is increasing. And F increases from 1 to 3 and 3 to 6, okay? Yes, you could definitely say that in another way. All right, here we go. E, where do we have a relative min or max? Well, remember, to do mins and maxes, go ahead, DeFore.
On the test, will they have like a trick thing like that? Because I haven't seen like a pointy place where it's like on the 3. Because it's not like an actual like straight visibly. Would that be on a test? Like, was that something we would have to look out for?
Well, I would look out for it. I would say that's definitely visible right there. Definitely it doesn't go in a straight line. Do you know what I mean? And then you know that this slope is up 2 over 2, right? But this slope is up 2 over 1, 2, 3, 4. Do you know what I mean? So they're definitely different slopes, right? And if they're different slopes right there, then that means it has to be a DNE in terms of the derivative, okay?
Yeah, because it's not differentiable.
Right, it's not differentiable there. All right, here we go. Relative extrema for G. Relative extrema means the first derivative. Remember, the first derivative of G, is really just F. So if I did extrema, or increasing or decreasing for G, I would do G prime, which is actually F. Well, then I would need to know when F is 0 or DNE, and F is 0 at 0, and F is 0 at 3. And then F is negative here, positive here, which means not F, but G will decrease and then increase, which means this guy here, we better know, is a relative minimum. Give me a thumbs up. Everybody okay with that? Now, what a lot of you guys will forget is they have endpoints. So that means you would have to tell me what this is. And hopefully we all remember that would be a relative max. And that right there would be a relative max. Give me a thumbs up. Are we okay? And the reason why I would have to do endpoints is because they gave me endpoints. Right? That's a huge problem. We do 3 problems like this one today because it's so important. All right? And you don't have to write them down because you guys have already done them. So if I were you, I would redo those. I would redo those. You guys have 90 seconds to either ask a question or do this next problem on Desmos. Go ahead, Palmer.
On the last one, it asks for the absolute maximum of G. We just put 0.
Absolutely. Oh, as the last piece for that one, what the absolute maximum is, and that is for G. Remember, you had 2 maxes, right? You had one at 0 and one at 8, correct? It's going to decrease till 3, and then it's going to increase. So our actually absolute max would happen at x equals 8 because it increases way more than it decreases. Does that kind of make sense? Okay, but don't worry, there's too much involved with that last piece. That's why I skipped that last piece. Okay, Mr. Palmer? Which means it won't be asked on your test, okay? But very good question. Everybody, let's go. Ooh, if you didn't do the dance yet, you got an opportunity to get a second bonus point. Who wants to do the dance? This question says average value. Anybody that didn't dance yet that wants it? Anybody? Oh my gosh, you guys don't want bonus and the semester's almost up. Darn it. Who already danced that I owe a bonus for dancing? It was Seiko and DeFore, right? That's it? All right, you guys, they're going into the test with 2 bonus points if they answer everything today. But remember, it's just integral divided by the interval. Whenever you hear the word average value. Remember, average rate of change is something way different, but if it says average value. All right, unfortunately, I can't give a ton of time today. I already got some answers, which I love. So this would be the integral from 0 to 2 of your function, okay? And you'd have to divide that by the interval. That's it, you guys, that's it. Now, it's very important to pay attention to. This question could be calculator or non-calculator. If it's calculator, you just math 9 it. Math 9, that's it. But if it was non-calculator, and FYI, if this was the actual question, it would be non-calculator because it's very easy to do the antiderivative, which would be x to the 4th over 4 minus x squared over 2 plus x. And I'm going to evaluate that from 0 to 2, and I'm going to divide by 2. Remember, using the FTOC, you plug in the 2 first, which gives me 16 over 4 minus 4 over 2 plus 2 minus 0 plus 0 all over 2. And if I did that work, it would be 4 minus 2 plus 2 all over 2. It'd be 4 divided by 2, which is 2. If you want bonus, you better have your cam on, and you better put 2 as your answer for number 4. That's how easy it is to get bonus today. It's how easy it is to get bonus. Go ahead, DeFore.
So we don't do the plug in the 2 into the function and then minus the plug into the 0 of the function?
For sure you do. That's what I did. I plugged the 2.
I don't get why you're at 16 over 4 then.
What's that?
Because I plugged in, I don't know if this is right. I did 2 cubed minus 2 plus 1. That's in its own parentheses. And then minus 0 minus 0.
No. Don't you dare do that. You got to take the antiderivative first.
Oh, okay.
Yeah, DeFore, don't do that. That'd be bad. Okay, that'd be bad. You got to take the antiderivative first, then you plug in the 2, then you plug in the 0, okay? All right, any questions? Remember to give me a thumbs up if you're good. Any questions? And you guys keep on using that little hand raiser on your Google Meets. It actually gives me a little sound, and it's obvious. Now, I'm going to cross my fingers My computer hasn't shut down yet, but I would not be surprised if it does, okay? You guys remember, if it does, you're on your own until I get back. And here we go again. Sit back, relax. See if you can answer these questions. And you know what? I don't know about you guys, but that looks awfully small, that picture. So I'm going to make it a little bit bigger here so that you guys can have it bigger. Can I even make it bigger? I'm going to try to. All right, if it comes up, it comes up. All right, here we go. So once again, can you answer these questions? All right, it's asking me what G, okay, oh shoot, it goes off the screen. What the what? Gosh darn Jamboard. Okay, there it is. It's bigger. And I still have the question there. So let's go ahead and do it. Okay, first question. What's G of 3? What's G of 3? Well, G of 3 means I just put a 3 in for x. I hope everybody would know what to do right here. I hope so. Okay, that would be the area from 2 to 3. Which guess what, class? That's a trapezoid. That's a trapezoid, which is 1/2. The height is 1. The height is 1. And my bases are 4 and 2. So that answer is 3. Give me a thumbs up. Are we okay? If you're able to do that on your own, you're good to go. Should be feeling awfully good about yourself. You really should. Okay, but it obviously gets tougher. What's G prime of 3? Well, G prime of 3, remember, is the derivative of an antiderivative. G prime of x is equal to f of x. So G prime of 3 is f of 3. Well, what's f of 3? 2. Give me a thumbs up if that's okay. Man, I would love it if we did well on this test, because this test can be tough, but I've got to find a way to condense it, obviously, which makes it easier for you guys, so take advantage. What's G double prime of 3? How the heck do I find G double prime of 3? Well, I need to know what G double prime of x is, which would be f prime of x. So that means G double prime of 3 is equal to f prime of 3. What the heck is f prime of 3? F prime of 3, 3's right here, 3's right here. F prime means slope. What's the slope of that blue line? Well, it's just down 4 over 2. Down 4 over 2, it's -2. That's my answer. Give me a thumbs up if we're okay with that one. That one was by far the toughest. If you were able
So you could do that whole line.
Well, isn't that where 3 is?
So even if it asks for like 2.5, that answer will be the same as 3.
Outstanding. Outstanding. So obviously, if it asks like G double prime of 6, you would use the green line, right? Okay. Or where would we have DNEs? You know, where would the second derivative be DNE? Well, G double prime would be DNE whenever the slope of f is DNE. So it'd be DNE at 2, 4, and 5, right, everyone? 2, 4, and 5. I guess this picture is even better, right, to 4, because you can tell that it does change at 4, right, because it's a different color. Or you could even find the slopes. Question, I heard it. Who's got a question? Nobody, maybe it was an email. All right, I see no hands raised up, so I'm going to go. Okay, I don't see any.
Haley raised
Mr. Tanaka, I have a question.
Okay, oh, I'm sorry. There it is right there. Darn it, Miss Carrier, what you got for me?
Is it always going to be like G prime of x equals f of x and G double prime equals f prime of x?
I hate the word always, right? Because always and never are really difficult words. I would say 99% of the time that would be accurate. Okay, Miss Carrier?
Okay.
Here we go. Ooh, man, B is awesome. Average rate of change. I just want a thumbs up, thumbs down. Is average rate of change the dance? Good job, thumbs down. Average rate of change is just this, you guys. G of 3 minus G of 0 all over 3 minus 0. Got it? That's it. G of 3 would be the area from 2 to 3 of that graph. G of 0 would be the area from 2 to 0. I'm not going to do that with you guys. All right? I'm not going to do that. It's more important that you knew what that meant. Okay, just be careful that if you did the g of 0, it would be from 2 to 0. 2 to 0 is backwards. So you would have to put a negative out in front and go from 0 to 2. Are there any questions? Give me a thumbs up if you're good, you guys. I need thumbs up. I'm not going to give you bonus if you're not communicating with me. All right. And we're not going to do C. Okay, we're not going to do C. But I hope you guys are feeling pretty good about that because that's a star problem. That is a star problem. All right, here we go. I want you guys to get this before I'm done, and you should be able to with only 60 seconds. Let's go. And we haven't got kicked out yet, so I can give 60 seconds. You cannot miss questions like this because on your test, they will be all or nothing. I want to check. I'm going to check here in my Desmos to see how we're doing. Man, I've already got 5 people and they all got it right. I love it. That means they're doing their worksheets. I will almost guarantee the answers that I already have in there, they do a great job of doing their worksheets. I'll guarantee it. And remember, you better put the right answer in here. Actually, I don't need the right answer. If you got it wrong, I would actually rather you leave it wrong, but you better have an answer in here. If you don't know how to do it, then you wait till we do it and you put in the right answer. Actually, you know what? Do me a favor. If you don't know how to do it, you put a question mark because I would like to see where we stand. Okay, you don't get any credit. You just get bonus for being honest. So if you don't beat us on this one, put a question mark. All right, how do you do this one? It's the derivative of an antiderivative. How do I do those? Well, you just go straight to the FTOC. You plug in this into the t. So it becomes e to the 2x cubed. But remember, since it has an x, you got to chain it, which is the derivative of what you plugged in is 6x squared. And then it's minus, plug in the 3. The 3 is a constant. So if you plug in a constant, you get a constant. Then if you take the derivative of a constant, you get 0. So the answer is B, 6x squared e to the 2x to the third. Kudos to you guys that got that right. I know you're doing the worksheets. I know it. Ooh, I heard it. Let me see if I can see it. Slater, go for it.
Yeah, so don't you take with the bottom part of the integral minus the top parts when you plug it in?
No, you always do the top first. Always.
No, like you do the top minus the bottom.
You do the
Instead of
top
the bottom.
minus, you do the top minus the bottom, but this time the bottom, since it's a constant, the derivative of a constant is 0, so it goes away. Always do the top minus the bottom. That's the fundamental theorem of calculus.
Oh, we did the bottom minus the top in the last one.
Never.
Oh, no, we did. Okay. Yeah, I got it.
Okay, we always do the top first. I would never make that mistake, Mr. Slater. I guess well, right, Miss Courier? Should never use always or never. All right, here we go. Star this bad boy. This one you should write out. Right?
Mr. Tanaka.
Who's got me? Go ahead, Miss Courier.
I had a question on the last one for how did you get 0? Because I thought it would be e to the third that you take the derivative of.
Okay, what's the derivative? What would the derivative of e to the third be?
3e squared.
No, it'd be 0. It'd be 0 because it's a constant. E to the third is actually a constant. It's a number. There's no variable in it. Remember, the derivative of anything that doesn't have a variable in it is 0. Everybody got that? Like the derivative of pi is 0, right, you guys? But for some reason, when we see an e or we see a pi, we think it's a variable. It is not a variable. Everyone with me, yes? Can I get a thumbs up? Yes? Okay. And we're going to do another one of those pretty soon. But remember, all you need to be concerned with, Miss Courier, is that says dx. So just focus on where you have x's. If you don't have an x, it's going to be 0. Everybody got that? It's going to be 0. It doesn't have an x in it because we're going to take the derivative of the x at the end. And if it doesn't have an x in it, that means it's a constant. And if it's a constant, the derivative of that will be 0. Okay, here we go. Copy this problem out. It is huge. Star number 2, right? Star number 2. This problem is huge. Total area versus area. Here we go. Area. I was allowed to use a calculator. 0 to 3 of 2 minus x dx. Do the problem. Total area. Total area. Total area is from 0 to 3 of the absolute value of 2 minus x dx. Okay, this one here, piece of cake to do. This one here, much tougher to do. Okay, if it was area, you just do the problem right now. Antiderivative, plug in the 3, plug in the 0. Okay, this one here, if I was not allowed to use a calculator, and this would be no calculator, no way. Okay, no calculator, no way. Sometimes on the AP, this could be on a calculator, and you better remember to just use your calculator. And all you have to do is put an absolute value around the function. Okay, but the only way to do a total area problem without a calculator is you better know what the graph looks like. All right? And we all hopefully know what 2 minus x looks like. It's got a y-intercept of 2, and then we go down 1 over 1, down 1 over 1, down 1 over 1. There's the graph. Okay? And they're asking me for the total area, which would be this green area from 0 to 2, which is above. If it's above, it's going to give me a positive area. Yes, everyone? But if it's a negative area, it's negative from 2 to 3. That's going to give me a negative answer. So what is the total area? So guess what, class? We got to split this up. We've got to do it from 0 to 2. That's going to give me a positive answer. Let's do it. The antiderivative of 2 is 2x. The antiderivative of negative x is negative x squared over 2. And I'm going to evaluate that from 0 to 2. You always plug the top guy in first, which gives me 4 minus 4 over 2. Minus 0 minus 0. So this gives me an answer of 2. So this area right here is plus 2. Give me a thumbs up if we're okay with that, please. Right? Very good. Okay, so that area is a positive 2. Now, guess what? I've got to do the integral from 2 to 3. And if you're super duper smart, you know that this has to be a negative answer. Correct, everyone? Why does it have to be a negative answer? Because it's below the x-axis from 2 to 3. Now, we should know from 0 to 3, my answer would be positive, right? If I did just this area, my answer would be positive because the positive area is definitely bigger than the negative area, okay? But let's go ahead and do this. I better get negative as an answer. So it's 2x minus x squared over 2. I already did the antiderivative, but this time I got to do more math because I'm going to go from 2 to 3. And Mr. Slater, a lot of people make this mistake. Because when I say 2 to 3, we think to plug in the 2 first, right? Because that's how we are supposed to say the integral from 2 to 3. Remember, when using the FTOC, you better always plug in the top guy first, which is 6 minus 9 over 2 minus 4 minus 4 over 2. Oh, snap. I'm going to have to do some common denominators. 6 is 12 over 2. This right here gives me an answer of 2. Okay, and I'm going to subtract 2, which would be 4 over 2. And if I do all my math correctly, that gives me an answer of negative 1/2, which is right. Which is right. I actually could have done triangles for this too, right, class? If you're really smart, you could have said, Mr. Tanaka, those are triangles. I didn't even have to do the antiderivative. But why did I do antiderivative? Because most likely it's going to be curved on your test. Everybody got that? Yes? Okay, so what the heck is the total area? Well, guess what? The area would be 2 plus negative 1/2, which would be 3/2. Okay? So the actual area from 0 to 3 is 3/2. That's your positive added with your negative area. But the total area would be 2 plus the absolute value of negative 1/2, which would be 5/2. So the answer to this question is 5/2. This is a very, very important question. Important question number 2. Are there any questions? Remember, thumbs up if we're good. Give me the little icon if you got a question. Oh my gosh, I'm so excited. Cross my fingers. Cross my fingers. Please do not shut down on me, computer. Right, I'm recording this. Oh no, God, I just freaked out. Thanks a lot, Daly. What's your question, Mr. Daly?
You did 12/2 minus 9/2 minus 4 over 2. Where did the -4 go?
The -4. Oh, because darn it, and I erased it. But it was 4 minus 4/2. Remember that?
Yeah.
And then I'm sorry. So this right here would be 4 minus 2, which would be 2, right, Mr. Daly?
Oh, yeah.
And I didn't write it all out. I apologize.
Yeah, I got it. Thank
No,
you.
but I should have wrote it out. Okay. But you know what, Mr. Daly? I really appreciate you asking that question. I really do. You've got 60 seconds to do the next question. It's another one of those derivative of an antiderivative questions. It's a tough one. All right. So let's see if you can get it in 60. If 60 is not enough time, I'm sorry. You're going to get much more time on the actual test day. But you want to challenge yourself right now, see if you can get that. And guess what? I bet you if you've been working super hard, you already know how to do this. I've already got answers on there. And so what your job is just keep on going on Desmos, okay? Just in case, once again, fingers crossed, okay? Just in case I get booted out of here, okay? Make sure you work on your Desmos. Okay, hopefully it was just a glitch and my computer is done with that glitch and it won't crash anymore. Ooh, good, I'm getting more and more answers in here. And what's crazy is right now, all these answers kind of look similar, okay? The good thing is I don't see anybody putting an A down there, and there's no way it could be A because you're plugging things in for the T, and we're plugging X's in for the T. Okay, so it should be a dead giveaway it's not A. Man, if I had to guess, I don't know if I would guess D, because D is just kind of weird that it's 0, but who knows, maybe it is 0. All right, if you're not sure how to do it, put a question mark. Okay, got just like 15 more seconds. If you're struggling with these questions, I hope I get to see you guys tomorrow. Remember, I'm always here 7:30 to 8. And believe it or not, I'm going to have a study session because it's our last test tomorrow after school from 1 to 2. So if you need some extra help, show up from 1 to 2 tomorrow. I'm also going to be here from 7 to 8 on Monday morning. Okay, but here we go. Let's do it. You got to put a question mark if you didn't get an answer yet. All right, but here we go. It's the derivative of an antiderivative. So you go straight to the FTOC, which means I'm going to plug a x squared in for every t. So it should look like this. But then I got to take the derivative of what I plugged in just one time. Just one time. Okay, I know I plugged it in twice, but you just take, when it chains, it just takes the derivative of the inside, and the inside was x squared, and the derivative of x squared is 2x. Minus, now I plug in the bottom guy. Okay, and I'm going to plug in that bottom guy wherever I see a t. But then I got to chain what I plugged in the bottom. And the derivative of negative x squared is negative 2x. And then I'm going to simplify. X squared and 2x gives me 2x to the third. Then I'm going to simplify in here. It'd be 4 minus x to the fourth. And then I have 1, 2. I've got 3 negative signs. 3 negative signs makes a negative. Oh my gosh, I got the same exact thing. Well, if I get the same exact thing, what's my answer, class? 0. So I never would have chose D if I was guessing. Okay, but it's definitely D. It's 0. You get the same exact thing. And if you subtract the same exact thing from itself, my answer is 0. Only about 33% of you got that right. Give me a thumbs up if we're okay. If you got a question, hit that little thing. Okay. If you got that right, kudos for you. For the 33%, you guys did a really good job of simplifying. I heard it. What's up, Daly?
Under the second radical, why wouldn't the x be positive?
Do you mean this guy right here?
Yeah.
Please excuse my dear Aunt Sally. Means I have to do an exponent first. So when you do negative x squared.
Oh, I got it. Yeah.
Got it?
Yeah.
Daly, I love the questions because you are not the only one thinking of it. I love it. All right, give me a thumbs up if we're okay to go on, please. All right, and we're doing great. We still have about 20 minutes left, and I've got to talk to the juniors a little bit today. Okay, here's the question again. Let's talk about this. This is where you get to sit back and relax. This is the third time I'm doing a question like that. What does that mean?
People have questions.
Oh, somebody did? Oh, Miss Carrier, go for it.
How do you know when to start with the FTOC or when you should just start taking the antiderivative?
Oh, great question. So,
Yeah, that was my question too.
what a great question. Remember, okay, I taught you in a video how to do this problem the long way. The real way to do this problem is you do the integral, then take a derivative. That's what this one asks you. But that's way too much work. So for these problems, we use a shortcut. And the shortcut is we go straight to the FTOC. So to answer Ms. Currier's question, when you take the derivative of an antiderivative, you go straight to the FTOC. Got that, Ms. Currier? If the problem was just this, you do the antiderivative, then you do the FTOC. What's the difference between problem 1 and problem 2? Problem 1 has this d dx in front of it, right, everyone? So this is the derivative of an antiderivative. You do the shortcut, which means you go straight to the FTOC. This right here does not have a derivative, so you just take the antiderivative, then you go to the FTOC. I hope that helps out Miss Currier. Are we okay? All right, that's a big difference here, understanding the difference between those two. And you know what? I will reiterate it when we do this next problem, because it is involved in this next problem also. So you guys sit back and relax. This guy's a little bit different. This guy here says that h of x is equal to the integral from a to x of f of t dt. Now, the only difference here is x is a variable, a is a constant. Okay, a is actually a constant. So the first question they ask here in A is what's h of 0? H of 0, that means you put a 0 in for x. Now this question just wanted you to put that. That's it. We don't know what a is. So it depends on what a is. Okay, but if you notice, if it goes from a to 0, that's backwards. So remember, anytime your limits are backwards, you should flip them with putting a negative on the outside. And you have to do that whenever you're using a picture to do a problem. Give me a thumbs up if we're okay, please. Okay, let's go ahead and do this guy now. Let's do B. It says, and this is such a good question, when is h increasing? Well, h would be increasing whenever h prime is positive. Well, when is h prime positive? So, Ms. Curie, I'm trying to do h prime. Mr. Four, you asked this, right? H prime means derivative. So I'm going to take the derivative of that. So I'm going to take the derivative of an antiderivative. That means shortcut. That means FTOC. That means shortcut, which means I just plug that in for the t. and then you take the derivative of x, which is 1. Now, I said a was a constant. If you put an a in there, which is a constant, you will get a constant. And when you take the derivative of a constant, you get 0. So h prime of x is equal to f of x. Give me a thumbs up if that's okay, you guys. It's a very difficult concept. Okay, if you're getting it, you're going to ace this test. All right, increasing, decreasing. I like to do sign analysis because it answers all of the questions. So sign analysis for h prime would be critical points for h prime. So when is h prime 0 or DNE? Well, it will be whenever f is 0 or DNE, which happens at 1, which happens at 4, and which happens at 8. So at each one of those points, f is 0 or DNE. Give me a thumbs up if that's okay. And then f is positive, then it's positive, then it's negative. So I would say h is increasing whenever the derivative is positive, which would be from 0 to 1, union 1 to 4, because h prime of x, which is equal to f of x, is greater than 0. Man, this is the third one we've done like this, so I hope it's making sense. Okay, I really do. Right, and if h increases, then decreasing, that would be a max, that would be a min, that would be a min. Right, everyone? Okay, taking it a step further. Put your hand up if you have questions. If not, I'm going to keep on rolling because the next question asks for concavity. Now, if the next question asks for concavity, that would be h double prime of x. Well, h double prime of x would be f prime of x. Well, f prime of x means it's the slopes. And I have to use this because that's all I was given. So when are the slopes 0 or DNE? At 1, at 3, and at 6. And then h double prime is f prime, so the slopes are negative, positive, negative, positive. Right, everyone? And so when is this dude concave up? It would be from 1 to 3, union 6 to 8. Why? Because h double prime of x, which is equal to f prime of x, is greater than 0. Which would mean 1, 3, and 6 are points of inflections on the graph of h. Remember, we are not given the graph of h. We are just giving information about the graph of h. And h has to have points of inflections at 1, 3, and 6. Not f, but h. Give me a thumbs up if we're okay, please. Okay. The last questions just ask about, well, we'll do one more. E and F asks max and min. I've already talked about that stuff. So we're just going to talk about h of 8. Well, h of 8 would be equal to a to 8 of f of t dt. And a lot of you would say, well, I can't answer this because I don't know what a is. But believe it or not, it doesn't matter what a is. It doesn't matter. This area is all negative, right, everyone? That area is all negative. This is a very small positive area. This is a small positive area. It does not matter what a is. Your answer will always be negative. It will always, right? If a is 0, it's negative. 0 to 8, that'd be negative. 3 to 8, that'd be negative. 7 to 8, that'd be negative. It doesn't matter what a is. Your area from whatever a is all the way to 8 will always be negative because that negative area is very large. Give me a thumbs up if that's okay. That could have been a very, very difficult question, I think, had we not gone over it. Okay, it could have been a very difficult question. All right. Oh my gosh, you guys, we just really have to go over like 2 more problems. I'm going to be so excited, cross my fingers, that I do not get booted out. Okay, you want to have a question right now? If you want an A, if you want to get an A, you got to be able to get a question like this, right? And do we have enough time? I just have one other problem to go after this. Do we have enough time? We do. So I'm going to give 2 minutes. If you want to get an A, you would have to be able to get a question like this. Let's see if anybody can get it in 2 minutes, which probably wouldn't be enough time, but That's all I'm giving you. I want to see if anybody can get it. So you know, if you're somebody that like, what are these questions that Mr. Tanaka asked that he hasn't taught us in class, but we should be able to do? This is one of them. Oh my gosh, I already have 2 correct answers. It's crazy. It's crazy. Don't guess on here, okay? I don't want you guessing, so I don't want anybody guessing the right answer. And you know what I want you to do if you're at home? What if this was a test question? You should at least try something. Think about what chapter we're in. Okay, think about what chapter we're in and try something. All right, honestly. You can sometimes get a right answer by doing that. All right, what chapter are we in? And so you should try something. Yeah, I got, oh my gosh. I think I've got 10 people that answered. I got 5 of us with the correct answer. That's crazy. All right. So I probably shouldn't be telling you this, right? But what should I try if this was the problem? Well, we're in an antiderivative chapter. Maybe I should take the antiderivative of velocity. And guess what? If you did that, you would have got this right. You would have got it right. Ms. Curie, do you have a question?
No, sorry.
No, that's okay. I finally noticed it when you didn't have a question. All right, here we go. From 1 to 5 of velocity. Now, why would that give me the total distance traveled? Well, velocity is like miles per hour. In this case, it's units per second. And if we take the antiderivative of that, remember, it's like area. It's like area. So if it's units per second, and I'm going to multiply it by seconds, gives me the total amount of units that I travel, or miles that I travel, right? Or you could have thought, hey, the antiderivative of velocity is position. And how should I know that? Well, because the derivative of position is velocity. All right, so if I know my position, I'm going to know how much I travel. Okay, so for this one, it's just the integral from 1 to 5 of 1 over t squared. Now, some people will think that's a natural log. That is not a natural log, right? That's t to the negative 2. Okay, which that would be a power rule where you would add 1 and get a negative 1, and then you would divide by a negative 1, and then you do the fundamental theorem of calculus from 1 to 5. Remember, that means that you better plug in the 5 first. Actually, I'm going to rewrite this, right? That's negative 1 over t from 1 to 5. So if I plug in the 5 first, I get 1/5, negative 1/5, minus negative 1. 2 negatives makes a positive, so that'd be negative 1/5 plus 5/5, which is 4/5. And when I last checked, half of you got that right. Huge kudos to you guys. Huge. That's awesome. That is considered a tough one. So we're not going to go over it any more than that. But that's using everything we've learned in calculus so far. Because we learned about position, velocity, and acceleration. And that was just using what you've learned in this chapter. And conceptually, if you kind of understood what's going on, you could have been able to get that right. All right. This is the triple star problem. This is the huge one. This is the mosquito problem. You did the review. This is the mosquito problem. Crossing my fingers has worked. We just got to get through this problem. Okay, we just got to get through this problem. I want you guys, you really should have this problem. So I want you to type down 2019 AP Calculus free response. And if you type that in Google, the question comes right up. It's an actual old AP question. That's why this question is so important. So write that out. Don't write out the actual problem, but write that out. Okay, but write that out. Okay. This question 100% will be a calculator question, just like the mosquito problem was a calculator question. So what I need everybody to do right now is get out your calculators. I am very scared to get my calculator out, so I am not going to. Okay? I don't want to lose you guys. I do not want to lose you guys. Actually, should I get it out? Man, I'm going to get out my calculator, you guys, but I'm going to be so mad if I lose you guys. But I think it will be helpful if I do get it out. So I'm going to get it out. Please don't crash on me. I feel like the more things I open, though, we crash. So please don't crash. Do me a favor as my calculator gets uploaded. What I need you guys to do is whenever you have these questions and they're calculator related, when they give you functions to work with, plug those functions in your Y1. Now this particular problem, right, you guys gives me two functions to work with. So let's plug one of them into Y1 and one of them into Y2. So I'm going to go Y1. I'm going to plug it in there. I'm going to move this down a little bit so I can plug it in. Okay, so it's, what is it? 20. Actually, I'm going to get it up here. And I have on another screen of mine, you guys, the actual AP question, because I Googled the AP question like I asked you guys to. Oh, no. They don't have the original. I just have the answers up there. All right, well, you guys are plugging this in. Ooh, somebody at home, DeFore, you like helping me out. Let's go. What is the first function you should plug into your calculator? Read it off for me. Oh, you can't read it off. Gosh darn it.
We can't see it.
20 plus 15 sine pi t over 6.
Yep.
So 20 plus.
So do the X for the T.
Yes. Yes. So 20 plus 15 sine, which means you better be in radian mode. I think there was a pi x over 6. That should be the first one. Okay, you guys can look at my screen. The next one is 4 plus 2. 4 plus 2, and then I know I'm going to raise that to some power with some freaky dude, 0.1 x squared. Enter. Okay, I'm going to leave that there. I'm going to minimize it. It's still up on my screen, don't worry. I'm going to wait a moment to make sure you guys get those plugged in. Okay, question A. Actually, first I should read the problem. Fish enter the lake at a rate of E of t. Fish leave at a rate of L of t. E of t and L of t are both rates, so they're measured in fish per hour. Question A asks, how many fish enter the lake from midnight to 5? So I'm just talking about enter, and I'm just talking about the number of fish. Well, if I wanted to know the total number of fish, I'm going to do the integral of the amount of fish that enter. And I'm going to do the integral from 0 to 5. That's like the area underneath the curve. It's going to give me the total number of fish. So it's really just your ability to plug that in your calculator. So let's all get out our calculators. Okay? And we're going to hit, I'm going to get out of here. And I'm going to hit Math 9. Okay? And I'm going to go from 0, midnight to 5. Where did I put the enter in? I put the enter in Y1, so I'll hit alpha trace. I'll choose Y1 because that's where I plugged it in. I used X as my variable like DeFore was asking, so it's dx. And it says to round to the nearest fish. So I would round, that'd be 153 total fish. Give me a thumbs up if that is okay and makes sense. Hey, remember, this is the 3-star problem. You cannot get this one wrong, you guys. All right, next up. So you guys, please ask your questions when you have questions. All right, next up. What is the average number of fish? Oh my gosh, average number of fish that leave. That's the dance. That's the dance. It doesn't say average rate of change. It says the average number of fish that leave the lake. So that's just the integral from 0 to 5 of the amount of fish that leave the lake divided by the interval. That's it. That's how important that average value dance is, you guys, right? The integral over the interval, right? That's how important it is to make sure you know it and when to use it. So let's go ahead and get out our calculators. Once again, this is just your ability to plug it in. That's it. So once again, this is a Math 9 question. Math 9, and I hope you're doing this with me. Practice makes perfect. Whoa, I hit enter too soon. I didn't plug anything in. Okay, so this one here, we're from 0 to 5 again. But this time, it says the average that leave. So that means I have to hit alpha trace, and I'm going to choose y2 this time. But I still plugged it in with x's, so it's got to be dx. So there we go. 30. Ooh, I can't remember how it told me to round. If it doesn't say to round, you have to say 30.295. Let's see, did it tell us to round? What is the greatest? Ooh, it didn't. It did not. Ooh, I forgot to divide by 5, didn't I, you guys? Is that why somebody raised their hand before? I forgot to divide by 5. Divided by 5. Okay, what is your something else? So the answer would be 6.059. It does not say to round, so it's 6.059. What's your question, DeFore?
So I saw that when you do the Math 9, you could change what you have for D. So like, let's say instead of plugging in an X, you kept the T when you plugged it into your calculator. Would you have to, but then after you hit Math 9, would you have to hit DT instead of DX? Could that
What
still
that
work?
thumbs up means you could use any variable you want, DeFore. But don't get cute. Hey, don't get cute.
Okay.
Just use that X to be safe, all right? It's good practice. All right, here we go. By far the most important one is part C. Greatest number of fish. This is an optimization problem. I need to know at what time do we have the greatest number of fish. So in your head, you should say, well, how do I get the number of fish in the lake? The way you get the number of fish in the lake is the integral of the rate that they enter minus the rate that they leave. I mean, that should kind of make sense. Give me a thumbs up if that makes sense, right? To get the number of fish, you got to do the integral, right? Because that gives me, because if I just use E of t and L of t, those are just fish per hour. I need to know when I have the greatest amount of fish in there. So we are going to create a function just like we did in that mosquito problem if you watched my video. So I'm going to call it n of x. I'm going to call it n of x. Okay, the number of fish in the lake. When does it happen? Well, we start at 0 and we go to x. Okay, when does it happen? What is x? Between 0 and whatever time. It's 0 to 8, it says 0 to 8. And I just have to use a different variable, kind of like what DeFore was talking about. Okay, so that's why I used an x. I can't use a t again. I can't use a t again, and you're going to find out why in a moment. All right, but the greatest number of fish means you're going to have to take the derivative, right? Because that's how we always did optimization problems, because we always found a derivative. So somebody asked the question earlier. Remember, when do you go straight to the FTOC? Well, we're going to take the derivative of all of this stuff. Well, if I take the derivative, that is an antiderivative. So that means shortcut. That means shortcut, right? Derivative of an antiderivative. And the shortcut means you put an x wherever you see the t. And you could have used any variable you want, like DeFore said. You could. And that's what I get. If I plug in a 0, it gives me a constant. I take the derivative of that constant, it still gives me 0. So that's my answer. Now, if we go back to optimization problems, when we took the derivative, we wanted to know when it was 0. Right? We wanted to know when it was 0. Well, this right here would be 0 whenever E of x equals L of x. Give me a thumbs up. That makes sense, right, everyone? Well, when does E of x equals L of x? Well, get out your calculators. And I kind of have to go quickly here. I'm supposed to talk to the juniors. I just looked at the time. Okay? And we're going to hit window. And I'm just going to hit, I'm going to hit zoom 6. Standard window. It's going to graph both of these. Remember, E of x was y1. Remember, L of x was y2. So guess what? They're going to be equal to each other wherever they Wherever they intersect. Good job, Miss Tracy, I saw it. Wherever they intersect. And they have to intersect in between 0 and 8, right? So if you look, the red one does look like it intersects the blue one between 0 and 8, but I'm going to have to fix my window. I'm going to have to go a little bit higher on the Y. Let's go a little bit higher on the Y. I'm going to go all the way up to 50 on the Y just to be safe. I want to be safe. Okay, and I'm going to put a 0 in for on my scale. And then I'm going to fix my X scale because it says here that T has to be between 0 and 8. Between 0 and 8. Boom. Then I'm going to hit graph. Oh, no, I did.
Yeah, I said 5.
Gosh darn it, I did something wrong. I got to go back. I got to wait till it's done graphing.
I tell you, but
Thanks, Mr. Dahl. I plugged something in wrong. You guys should hopefully get it right. My window messed up. I got to go back to window. It won't go until it's done graphing. Okay, finally, done graphing. Window, 0 to 8. There it is. I got to go to 50, right? That's what we said. 5, 0, 5, 0. There we go. Now graph. Now I should be able to find out where it intersects. You guys go ahead and find it. If you're really good and watch the mosquito video, you hopefully remember that you have to store your answer, right? We have to store our answer. Okay, and I'll tell you how we're going to use it in a moment. Okay, boom, boom. All right, so they intersect where the red meets the blue, which would be second calc. Intersect button is number 5. Enter, enter, enter. There it is. 6.2035644. That's where they intersect. So that means it could be a possible answer. I'm going to hit second quit. I know I did this in a video, but I will do it again. You hit the X button. The answer comes up, and you better store it. You're not allowed to round in AP Calc until you have a final answer. Boom. Okay, now I'm going to go back to my thing because I got to get done here, you guys. I got to get done. I apologize, but I've got to get this problem done. Ooh, why am I over here? Uh-oh, don't, okay. All right, so I'm still here. And so remember, now I need to know when do I have the most fish in there, okay? So my 6.20356, right? That was my critical point. But I also have endpoints of 0 and 8. So you have to plug all 3 of these guys into your end function. So from 0 to 0, hopefully we all know that answer is going to be 0. If you go 0 to A, and this would all just be math 9, you guys, you get 135.01492. And if you go from 0 to 8, you get 80.91998. And so the max is obviously right there. So the max happens at 6 o'clock and some change because it was 6.20356. Man, I went through that pretty quickly because we are already at 10:26. I apologize for that, you guys, because it was pretty darn fast to end it. But I'm glad I gave you some opportunity. I'm just so excited that